In this session, we will discuss the grooving cycle. What is grooving operation in a turning machine? Grooving is a type of specific turning operation that forms a narrow cavity of a certain depth on external, internal surfaces, cylinders, cones, or a face of the part, face grooving. This is the raw material. In this raw material, we need to create this type of component. For this component creation purpose, we have to do a grooving program. Let's start a discussion on the grooving operation for the selected drawing. In this drawing, we need to find out the minimum and maximum diameters of the groove and the width of the groove. These parameters will help us in selecting the proper tool. So go to the drawing. In this drawing, the groove minimum diameter value is 60 mm and the maximum diameter value is 80 mm. Then the depth of the groove is 20 mm. The width of the groove is 20 mm. This is our WCS for grooving operation. Here, X is 0 and Z is 0. Now let's see how to make a grooving operation in the controller. Let's move on to the software. Select the machine and start the simulator. Next, adjust the speed override and feed override. The machine required a reference. Click on X plus and Z plus. Next, go to the Program Manager for new program creation purposes. Click on the New. The program name is Grooving. Click on OK. The new file is opened. Start the program. Header G18, G90, G64, G71, G95. Next, G75, X0, Z0. Next, M06, T4, D1. Next, G96, S500. LIMS equals 800. M03. Next, G00, X85, Z50. Next, Z5, M08. Next, G01, F0.2. Next, groove cycle. That cycle is available in the turn option on the horizontal keys. Click on the turn. Go to vertical keys. These are the can cycles. We go to the groove cycle. This is cycle 93. These are the parameters available in this cycle. Now we will discuss them one by one. First, we need to decide on any one reference point to make a groove. That's the X80 and Z-40. So for this reference point is the groove starting point. SPD and SPL, starting point. These coordinates can be used to define the starting point of a groove, starting from which the form is calculated in the cycle. SPD is 80 mm. SPL is -40 mm. Next, WIDG. It means the width of the groove. That can be calculated from drawing. That is 20 mm. Next, DIAG. It means groove depth. That can be calculated from maximum diameter of the groove to minimum diameter of the groove. That is 80 mm minus 60 mm, so the difference is 20 mm. But while mentioning in DIAG we have to give radial value. So we have to give here is 10 mm. Next, STA1. It is used in special grooves like face and taper. Next, ANG1 and ANG2. It means flank angle. Asymmetric grooves can be described by flank angles specified separately. The angles can assume values between 0 and 89.999 degrees. Here we don't have any inclined flanks, so need not give any values. Next, RCO1, RCO2. It means radius or chamfer at the outside corners. And RCI1, RCI2. It means radius or chamfer at the inside corners. The form of the groove can be modified by entering radius or chamfers at the margin or at the base. It is imperative to enter the radius with positive sign and the chamfers with negative sign. We don't have any radius or chamfer, so need not to give any values. Next, FAL1 and FAL2. It means finishing allowance. It is possible to program separate finishing allowances for groove base and flanks. During roughing, stock removal is carried out up to these finishing allowances. The same tool is then used to machine a contour parallel cut along the final contour. In flanks, select stock of 0.4 mm and groove base 0.2 stock for finishing. Next, IDEP. It means end feed depth. You can divide the total grooving depth into several depth end feeds by programming an end feed depth. After each end feed, the tool is retracted by 1 mm for chip breaking. IDEP selected is 1 mm. Next, DTB. Dwell time. The dwell time at the groove base should be selected such that at least one spindle revolution is carried out. It is programmed in seconds. DTB selected 2 seconds. Next, VARI. Machining types. The machining type of the groove is defined with the units digit of the VARI parameter. It can assume the values indicated in the illustration. The tens digit of parameter VARI determines how the chamfers are taken into account. VARI 1 to 8 is the chamfers are calculated as CHF. VARI 11 to 18 is the chamfers are calculated as CHR. Select VARI is 5 or 15 for our OD groove machining. Next, VRT. Variable retraction path. The retraction path can be programmed in the VRT parameter on the basic of the outside or inside diameter of the groove. For VRT equals 0, the tool is retracted by 1 mm. Click on OK. Groove cycle is added. Next, footer. G00. X85. Z5. Next, G75. X0. Z0. M5. M9. G97. M30. Go to the offset and check the tool. The groove tool is not available. Now we create a new tool. Go to the new tool. Select the grooving tool. The tool number is 4. Select the edge position number 3. Click on OK. The tool is added to our tool list. The X value is -100. And Z is -100. The tool nose radius is 0.1. Next, the tool required width for the grooving. Choose the 5 mm. Next, go to the program. Now, go to the simulation. Activate the auto mode. Next, click on the cycle start. This is the tool path of our program. Next, add the raw material for better visualizations. Go to the More. Click on Material Removal. Add the raw material length and diameter. Length is 80 and diameter is 80. Click on Save. Adjust the material. Next, click on Cycle Start. This is our groove. Check the values of the groove. The width of the groove is 20. The depth of the groove is 10. The groove cycle is completed.